Well, good morning, ladies and gentlemen, and welcome to Grumman Pilots YouTube channel. And today we're going to modify the YAESU power supply, the FP1030 Alpha, which they use to supply 25 amps to their 12.3 volt radios. So we thought we would modify it. What could have possibly have gone here? Rats. I let out the magic smoke. Well, stay tuned while we talk about all the fun we had getting to this point. So we would like to ask you please subscribe, hit the like button, and hit the notify to stay current with our content. So, ladies and gentlemen, here's the backside on the smoke, the magic smoke coming out of the radio. You see that piece of aluminum tube from your elevator trim tab? Well, it's hollow. And you see me, I just picked up a cigar, I took a good breath of cigar smoke, and I'm going to blow it under the radio. Timing would have been better if I would have turned it on and then blown it under, but I can't bend over. But anyway, you get the idea that you turn it on and oh my gosh, the magic smoke came out. Well, nothing came out, but we took our time, we did all our wiring, we checked everything with an ohm meter before we actually went ahead and wired everything up and turned it on. So it's working very nice, the dimmer's fine, but we'll take you through the steps we did to put in this value added modification. As with any kind of a project like this, that potentiometer you see there on the right, that came out of a Fresh Arrow Easy Light. We had harvested one out of an older one, and we were using it to check the brightness. We also used a green LED that we originally chose, and we went with red finally, but we were just kind of get a feel for how bright and which direction the beam out of the LED went in. And as you can see here, here's the back of the panel on the front, so you can see the divot for where the USB dual port can go and our candidate spots where we're thinking about go ahead and putting things in. Now we're using that bigger 5K potentiometer as a mock-up. It was going to be kind of difficult to fit in, so we actually bought a smaller panel mount 5K potentiometer, and then here's the dual port with readout USB-C and USB regular connector that we're going to be installing in the front of the supply. Now here are all the candidate pilot drills, all drilled for everything for the 3 holes we're going to add to this panel, and it's a brave guy who drills and possibly voids his warranty. Now here's the smaller potentiometer, and we're already starting to build up the loom. We got the power supply positive on it, and we're picking out our drills here for our holes. Now that's going to be for the panel mount LED on the top, and the bottom 1/4 inch drill is going to be for the shaft of the potentiometer. When you're putting the potentiometer in, be sure to clip off the little lead if you don't want to drill a little divot in the back so that it can't rotate around when you're trying to tighten it. But anyway, those are the drills that we use to drill those holes, and it's plastic, not hard to do at all. Now here's the pilot drill for the USB, but you can see the other 2 holes have already been drilled. We'll turn it around here and let you look at the other side. So again, drilling the plastic was not hard at all. Just be sure you have a vacuum to vacuum up all the little bits and pieces. Now that was using a Milwaukee 1 1/8 hole saw, 1 1/8 inch hole saw to drill the plastic. It made a nest of shavings, as you'll see when we do the video of the drilling. But anyway, there's all the holes drilled. Now we're going to clean everything up, vacuum everything, and now we're doing the first candidate fit of the LED, and that LED there is going to dim with the potentiometer to kind of give you a feel how bright the gauge lights are. Now the 3 LEDs are going to be wired in parallel, so we're dimming them all at the same time. Those LEDs, by the way, are 1.06 ohms. We're using a 5 kilo ohm potentiometer, and our voltage supply is 13.8 volts. So there they all are mounted. Now they're not electrically hooked up here, but we're getting ready to start mapping out where the looms are going to go in the back and how everything is going to get soldered together. So that gets us to that point. We've got everything in place. Now it's time to think about installing the LEDs for the lights. The LED for the lights, they shine best straight out down the longitudinal axis. So we put a dollop of clear RTV in the middle of each gauge on the top, and basically just stuck the LED down in it, let it cure for 24 hours, and then we could loom up everything. And here's our diagram. We're going to take our power from the cigarette lighter, jump it up to the dual USB, jumper it out for the LEDs, and then return all the things back to ground. So here it is, turning on, and there's our LED right there, being by 13.8 volts, and that's at full brightness. So, and that also kind of gives you a feel for where the beam of the LED comes out. We had to examine that, where we would try to mount them on the side, But that was the best way, shining them straight down. We tested that one night, grabbed a small pair of hemostats, grabbed the LED, and we could twist it and turn it and point it right where we wanted while we were doing all of that. So as you can see there's what it looks like on top of the gauge. Now this is in full daylight, but you can kind of get the idea of what it's going to look like later. We wanted to add that in case we were in a dark shack and we wanted to be able to see what the voltage and the amperage was that we were supplying to the radio bus. So there you go. That's how it all, and as you turn it off, it'll slowly cascade down through the resistors that are built into the power supply, and the bulb will get dimmer and dimmer. So now stand by for the next bit. So here's the mock-up we made on heavy cardstock, laying where everything's going to lay out. That's where the overload is, and that's where the USB is going to go, and that way we could position everything, looking at all the bits and pieces we were going to be using. We made a second mock-up to hold up to the backside to make sure that when we drilled we weren't going to hit any key circuitry or any key components. They put all their LEDs and controls on little circuit boards, which are affixed with hardware, so we couldn't change out the color of the overload or anything like that. So we're just kind of going where the comes out of the cigarette lighter. We will go ahead and go into those solder joints, and that will be our bridge up to the USB. Now here's everything laid out on the table as we're getting ready to work. And as with any project of this time, again, it's very important you just take your time and move along and follow your plan. As we were going this, we used a second camera to catch up the close-ups as we were going through the drilling and the mounting of stuff, but you'll get the idea here in just a second. So we laid everything out, the Milwaukee 1 1/8 inch hole saws right there, as well as the drill bits we've already talked about. So we'll just move along here, and as you can see, right there we're marking where the drill bits are going to go on the front panel where we've already drilled the holes, but now we're laying out that we're actually going to go do that. So stay tuned for the next little bit. And as you can see here, I've just put my smallest drill in for my pilot drill. Now we're going to drill where the potentiometer is going to go. Then we're going to probably drill in the center where the LED for the panel mount is going to go, and then we will drill a pilot for the center of where the dual port USB. And we were just taking our time. It was plastic, so not like we were drilling metal, which I would have been worried about because you don't want metal shavings on the inside of a power supply. Checking the first hole, everything looks good. So now we're going to go on and do number 2. I'm going to go ahead and fast forward through some of this for you because you've already gotten the idea. And now we've put the Makita hole saw in there, and this is where we're going to start making a lot of plastic shavings. Now we didn't put hardly any pressure into the plastic because those teeth are very sharp and we didn't want to just go right through the plastic and nick a wire or anything. But as you can see, we're going to turn out a lot of chips and a lot of shavings, and we just took our time the whole way through until we finally get it. We finally stopped and checked the depth, and we checked the back for any distortion that may have been going on. But I think at this speed it worked out fairly well, and we'll get to the end of this and then I'll be right back with you. Okay, the hole has been cut now for the dual USB. We'll clean it all up and we'll get all the debris off the table so it doesn't fall into our lap and everything else. But then again, it wasn't all that difficult to do. There weren't all that many sharp edges, and a small razor knife quickly chamfered all the edges so that they were nice and clean and nobody would get cut on it if we're doing this. But anyway, that's what we used. We're using the Makita drills, and again, we weren't using a whole lot of RPMs. We were taking our time, and now we're going to look at the back, and there's everything. And here I am going ahead and filming the other little film that we did. So now let me jump ahead to the next section. Now that all the holes are drilled, we're going to go ahead and install everything. We're going to start with the USB. I think we're not, because we want to get the other ones in because they were a little bit harder to do. But anyway, we're going to install the 3 components, map out our looming, and then we'll be back after we've done all the electrical work, and we'll get you to that part in just a minute. Okay, nothing fancy here. We're going to put in the panel mount LED. Then we're going to put in the potentiometer and check the back for clearance. And we're going to do the same thing with the dual USB. And then we will start the process of hooking up the electrical connection. So stay tuned for a little bit of that. So after we had it all back together, we thought we were going to be really clever. We plugged it in, nothing happened. The problem turned out to be that we had the soldering iron and that cord hanging in the same spot, and we just plugged the soldering iron back in after we unplugged it. So we fixed that, and then we were able to turn it on without a single problem. So, ladies and gentlemen, sometimes you just want to check everything. Electrical connections can be very much fun to troubleshoot. All right, well, the troubleshooting's been done, and we're about ready to come back into focus here, grab the camera in our hand again, and now we're going to flip on the switch, and hopefully this time we will have success. And you'll notice, ladies and gentlemen, we didn't have any smoke, but we do have the illumination of the two gauges. The covers and all are all back on. We can check the dimmer there. We had to file the little knob down. It set, and it was going to rub against the front panel. We didn't want to mar that, so we went ahead and we took a file and we shaved it down a little bit, and now it sits just a little proud of the panel, and it looks really nice. So ladies and gentlemen, I think this turned out fairly well. I mean, you can have a lot of fun with it. Now, that was the knob before it was modified, but that was when we were trying to figure out everything going on with it. And so now we'll have enough brightness or enough dimness, however we want it, when we go ahead and we have it hooked up in the shack. So a good deal. Like, again, a brave person who takes a chance of voiding his warranty. And then here's what it looks like with everything on. It's reading out 13.9. The gauge comes with the USB says it can read up to 0.2 high or 0.1, somewhere in that range. So it's always going to read just a little bit higher than the actual voltage. But ladies and gentlemen, that's what it looks like when you're all done. And we had a lot of fun doing all of that. Now, here we are. We're checking it all out with video this time, not just pictures. The nice thing about these little switches is these dual USB ports is there's a switch for turning them on and off. So if you were on a battery and didn't want to wear it down, you could do that. Now you'll notice that the potentiometer doesn't affect the readout for the 13.9 volt. It only affects the 3 LEDs, the 2 in the gauge, in the gauges and the one right there on the front panel to kind of give us a feel for it. And when you turn the panel off, you can watch everything die down and slowly get dim. Now at 7:30, it was still pretty daylight here, and we checked it out on the back porch, and as you can see here, we can have more than enough light for bright light. So we were just checking the panel dimness and making sure that the center was going to be about what we wanted it after doing all the calculations on the back of the envelope from the resistant values and the amperage that we wanted, and our supply voltage again was 13.8 volts, so that made it easy having that as a constant. And then after we were satisfied with what it looked like in the daytime, we waited till it got dark. Now you can see it here. It's a little bit better illumination. We can see the gauges a little bit more as we play with it. So ladies and gentlemen, if you've got a piece of equipment and you've got a value-added modification, be brave and go and attempt it. I think I'm going to like having these extra things in my radio, especially since the power supply works really well. So we hope you found all this useful and informative. Think about what you might want to modify for you. There's a lot of things you could do to modify your airplane. This just happened to be involved with ham radio. Thanks for watching and have a great day flying your Grumman.